สวัสดีครับ Let's go back to this coffee bean example again. So in this example, we want to test whether the mean of the coffee bean bags is indeed 368 grams or not. So we set the hypothesis. We set the new hypothesis to be mu equals to 368. And if the new hypothesis is accepted, the process is in control. And the new hypothesis and the alternative hypothesis is mu is not equal to 368. So the level of significance, which is alpha is 0.05. So in order to test this hypothesis, we randomly sampling 25 samples, and the average weight of samples is 362.5 grams. We also know that the standard deviation of population is 15 grams. So from this information, we can draw the distribution of the coffee bean bags like this. It is normally distributed, so its shape is going to be like a bell shape. Then in the middle is going to be the mean, which is 368 grams. And then the standard deviation is 15. So about here, okay, it's gonna be 368 plus 383. 368 plus 15, and then here is 383 plus 15. On the left side, it's gonna be 368 minus 15 here, and then here is 353 minus 15. We already know that the area under the curve is 1, right? And in order to test the hypothesis testing, let's go to this example. The Excel file, and we can draw the distribution of population from the information that we have. We know that the mean is 368, and the distribution is normal. It looks like bell curve, and then the standard deviation is 15. So it looks like this one. If we locate the sample mean, which is 372.5, it's gonna be around here, right? This is 372.5, and you can see that it is very close to the population mean, or the hypothesized population mean. Okay, this is sample mean. Okay, but for hypothesis testing, we cannot just use the population distribution to justify whether we want to accept the new hypothesis or not. We need to use the sample distribution on the right, and from the information that we have, it has the sample mean equal to 372.5, and because the distribution is of the population is normal, the distribution of the sample is going to be normal too. But if the distribution of population is not normal, if we have enough number of samples, like more than 30, we can assume that okay, it's gonna look close to normal. Otherwise, it will be t distribution. But just like I told you earlier, to make it easy, we can just use t distribution. Even no matter what distribution of our population is. Okay. So now the graph looks like this. It's like bell shape, and the center has the value of 372.5, and we have to calculate the standard error, which is like the standard deviation of the sample. And the standard error can be computed by, this is the standard error. The formula for standard error is going to be the standard deviation of population or samples divided by square root n. So it's going to be equal to 15 divided by square root 25. So the standard error is 3. And then now we want to find the range of the confidence interval, right? The range of the confidence interval, like this one. So this one is, something like around here and here, right? So it can be computed by plus and minus the sample mean with the error, and the error here can be calculated by using T alpha, and in this case it's going to be alpha by 2, and degree of freedom is going to be 1 minus n minus 1. So it's going to be equal to T dot inverse open parenthesis. So the probability is going to be 1 minus 0.05 divided by 2, comma, degree of freedom is 25 minus 1. Oops. And we have to time this t value by the standard error, which is cells I9. Oh. What? Where is? I8. Okay, so the standard error is about 6.2. So this lower bound is going to be 372.5 minus 6.2, and this is going to be 372.5 minus 6.2 plus 6.2. Okay, and it is 366.3, right? And this is 378.7. Okay, and we have to use this confidence interval to justify whether the hypothesized mean is in it or not. If it is in it, we accept the null hypothesis. If it's not, we reject the null hypothesis. So the hypothesized population mean is about 6368, which is around here. So with this, we can accept the null hypothesis, saying that there is not enough evidence to reject the null hypothesis, or the sample mean is not statistically different, is not significant difference from the population mean. So this is one way to do it, but in many textbooks, including Ajahn Robi Pim books, they convert this normal distribution here into standardized normal distribution with the standard deviation of sample. So this distribution will be transformed into the distribution standard normal distribution like this, and then we have to compute the test statistic. So the test statistic is set, right? If this one is normal distribution, if it's not normal distribution, it's gonna be t. But the formula is gonna be similar, so we just find the difference between sample mean and population mean here, and divide by the standard deviation divided by square root n. So in this case, it's going to be 372.5 minus 368 divided by 15 divided by square root 25, and we got 1.5 here. So 1.5 here, when we put it in standard normal distribution is here. So this is like maybe the position of the transform 372.5 into 1.5 here, and this is like 368, right? And the other thing that we need to find is to find the boundary, right? The critical region and critical value. So the critical value, as you already know, if this is 3 distribution, we use T inverse formula. If this is normal distribution, we use normal inverse formula. But for this case, I'm gonna use T distribution. So 3.inv dot probability is gonna be 0.05 divided by 2. Degree of freedom is gonna be 25 minus 1, right? So the first critical region or critical value is gonna be minus 2. The second one is gonna be T dot inverse dot 1 minus 0.05 divided by 2. Degree of freedom is 25 minus 1. So the critical value is around minus 2 and 2 here. So this is critical region. So with this, we can conclude that, okay, our test statistic is in exception region, so we accept the null hypothesis. In the PowerPoint here, instead of using t value, they're using z because they assume that the distribution is normal, so they use z instead of t, which is fine because in this example, the distribution of the population is normally distributed. So the distribution of sample is going to be also normally distributed. But if the distribution of population is not normal and the sample size is less than 30, we better use t distribution.